Okay, rather than watch video tutorials where some guy types code and we try to type the same code, I think that's good for you, but I don't think that's the way to learn code. As I said a couple times in the course, I think giving you code that works and letting you play with it, tweak it, that is how I want to teach coding. I believe that play and curiosity are the most motivating things in code learning, and so I want you to play and tweak existing code and see if you can make something of your own. This is how I believe most people learn to code, particularly those teaching themselves, and it's a great and kind of thorough way to learn all the things you need to know, and you don't have to learn a bunch of other stuff you don't need. This is an example from here. Well, let's go to Three.js. This is 3js.org, and here's the documentation. We already have a link to that on the canvas. We'll make another link to the examples, which is where we just at. So these examples, some of them look complicated and really aren't particularly. Some of them are quite sophisticated, but we're not going to do those. But I just wanted to show you some. You can maybe see this character is animated in an idle mode. Now she's walking. She smoothly transitions into running, and we can make things like her sneak as she runs. We're not going to. You may recognize this model and these animations as coming from Mixamo. I believe they do. We're not going to do that first. First, we're going to do something simple. I do want to point you out some that you might want to try next. This is fairly simple. These are just a bunch of nested spheres, one inside the other, but we can see into them because a clipping plane or a clipping shape, something has been made, a shape has been made to remove the visual representation of these parts of the sphere so that we can see inside. Making the sphere inside a sphere inside a sphere is very easy, and using clipping planes to create cutout holes is also quite easy. You could make a model of how the moon or the earth, the layers of the crust and the mantle and the magma and the core, or some other thing with an approach like this. This is known as decal, and I can paintball this guy. And the real cool part is the paint splatters match the geometry of the 3D model. You can really get inside that ear by just clicking on it. Not going to do that first. First, we're going to do something that is it's quite simple, but it's something we could not have done in A-frame, and it involves geometry and using geometry in such a way to create a lot of complexity without a lot of work. This is known as extrusion. Somehow I moved up and I didn't mean to. Anyway, this is known as extrusion, and you can see that the ends of this object, maybe you can see, are stars. The ends are stars. They're just exactly like that star, except without a red center. And this is also extruded. It's just a star shape that has been pushed through. You might think the geometry has been pushed through this shape. When we talk about extrusion, we may think of the Play-Doh Fun Factory. Goo or Play-Doh or clay is pushed through a hole with a shape, and then a ribbon of the stuff comes out with the same shape. So if I cut this ribbon in parts, they'll all look like this. They are star-shaped along a path. This red loop is, I believe, a triangle. Can you kind of see that there's a triangle that's been extruded along a path there? So this is a lot of complexity for a lot of bang for a little bit of buck. And this is what I want everyone to work with first, and then afterwards you can find something that you want to try of your own. Again, the goal is always to create something new from what you have here. I'm having a little trouble with the internet. So it'd be nice if there was a button that would allow me to download the code for these examples, but there isn't. but there is a way to do it. This whole page, the 3js.org site and everything on it, all these pages, are being run from here. This is a GitHub account. It's the account of Mr. Doob. Mr. Doob, here he is the creator of Three.js. He single-handedly created Three.js, but it's now been developed and maintained by hundreds, if not thousands, of people over the years. It's quite old, really, but it's always being refreshed and updated and perfected. And I don't know if you know, but you can run web pages from GitHub repositories, which is what's happening here. At the towards the end of the course, we'll create some of our own. So this is the page. You can maybe see examples. WebGL geometry convex. So that's just one example. Let's search this for examples. Search would be Control F or Command F, and I want the word extrude. And here it is, WebGL geometry extrude shape, and the other one is spline, and you can look at that and play with it too if you like. But this is the shape. Mr. Doob does something that I actually prefer in my own work. The tutorial we followed before had a HTML file and a JavaScript file, and the HTML is really minimal, just enough to run the page, you know. So I don't mind doing it this way with all the JavaScript in HTML file. This is an HTML file, and then by the time we get down to here, it's going to be JavaScript for a while, functions and constants and probably a for enumeration and maybe an if, you know. So this code, I can copy the code from this page. Here's the raw. I can copy the code from here and paste it into my Visual Studio Code, except for one thing we have to be aware of. And that is this script. This is again the import map, just like our first tutorial used. It's a little bit different than what I'm used to seeing. It's not a source with a URL, but an import map with several sources, and they have names. These have been named a little bit differently than our first example. This is the same: imports, colon, curly brackets, and then it has this 3, the name of the library. This is the library of code, and then another name. This is a different name than the first tutorial used, but the same file being referenced. However, these .. / notations, this is what we call a relative path. This is saying, look on the same server as this page, the WebGL geometry extrude shapes HTML. Look in the same server and find, what does it say, build / 3.module.js. Here's build 3.module.js. And so here's the raw. So this is not a relative path, but a absolute path. And since we're not going to have this code on our same test server, we should use the absolute path. So I have, let's go back. And are we, no, so let's find the extrude again. Extrude code. Somehow I'm searching over here. I want to search on the left-hand side. Here are, maybe I went too far back. Where are my examples? Here. I just hit the back button. So here are all the examples. So this is the page again that, yeah, tree master editor. Yeah. So if I search here, there's my shapes. So I can copy this code. Control A will select all the code and just the code in this window. Control C will copy it. And Control V will paste it. And I'll paste it into my editor. But I'm going to change one part. Pull this over. So this is my Studio Code, Visual Studio Code, and here you can see the only difference is this isn't build 3 module JS. It's the complete URL, and this one is called a little bit different from the last time. It's called 3/add-on/, and the other one just called it something like JSM, but it's the same link, the same URL. And so I've got, I don't know if it's the same URL, but this is the raw URL for this, for these examples, JSM, whatever that is, the add-ons. So I will copy this whole script and paste it into an announcement, or actually maybe on the page or something. But the main thing is, this is the only change I need to make to be able to do this. I had to disconnect that port. Let's reconnect the port. We'll go live. You can see I'm running it on my server. This is there. So now I can go back to my Visual Studio Code and begin to look at how this is made. And we'll look at it in class. I haven't actually given it much of a look, so we'll kind of figure it out together, and we'll begin to see if we can't make something from this that suits us and pleases us and doesn't look like the original, that Mr. Doob or whoever created the original would never recognize. That's the next assignment.